Hello everyone! In this Python scientific computing probability and statistics tutorial, we explain how to number 1. Generate a normal distribution with the prescribed mean and standard deviation in Python. Number 2. Compute normal distribution percentiles. Number 3. Compute values of a probability density function of a normal distribution. And number 4. Plot a graph of a probability density function of a normal distribution. This tutorial is largely based on the SciPy Python library. More precisely, we use a statistical function module called stats from the SciPy library. By the end of this tutorial, among a number of useful statistical computing techniques, you will learn how to generate this amazing graph showing the probability density function of a normal distribution. But before I start with explanations, I need to mention the following. It took me a significant amount of time, energy, and planning to create this video tutorial, as well as more than 450 video tutorials that you can find on my YouTube channel. And consequently, I kindly ask you to press the like and subscribe buttons. Thanks a lot. Okay, let's start with the explanation. First, let us briefly summarize the normal distribution. The normal distribution is characterized by the probability density function given by this equation. In this equation, mu, that is this parameter over here, is the mean of the distribution. The parameter sigma over here and over here is the standard deviation. Sigma squared, given over here, is the variance, and x is the independent variable. Let's start with Python coding. The first step is to import the necessary libraries. First of all, we need the NumPy library. Then from SciPy, we import stats. Then we import the plotting function. Let's learn how to define a normal distribution in Python. First, let's specify a mean value. Mean value is, for example, equal to 5. And let's specify the standard deviation. Standard deviation is equal to, for example, 5. To define the normal distribution, we will use the function norm from the stats module. Consequently, we will type stats.norm, where norm is an abbreviation for normal. We need to specify two keywords. The first keyword, called LOC, is the mean value. LOC stands for location. The second keyword is scale, and the scale is equal to standard deviation. The output of this function is our distribution object. I will call this object simply as distribution. Okay. Next, let's learn how to calculate the first 4 moments of this distribution. We'll type distribution. Then we will call stats. And let's specify what we want to compute. Moments are equal to MVSK. And the function will return mean computed. That's the first moment. Variance computed. Second moment, the third moment, and the fourth moment. Okay, so let's evaluate this piece of code, and let's see. Here is the mean, and that's precisely the mean that we specified, and here's the variance. Perfect. That's precisely standard deviation squared. Next, let's learn how to compute percentiles. To compute the percentiles, we will type distribution, and then we will call the method called PPF. PPF stands for percent point function, and over here let's specify 0.5. That is the 50% percentile. Let's see what happens. And we get 5, and that's precisely the mean. Perfect. Let's see what happens if we type, for example, over here 0.05 For example, if you want to get on the left side the score corresponding to 0.05, let's see what do we get. Perfect. And let's see this one. This is also a very important percentile, 95th percent. And we get this value. Now we can verify these computations, and we can verify that this function called PPF is actually working by computing the mean value of these two quantities. And the result should obviously be equal to the mean. This is because the normal distribution is completely symmetric. Perfect. So PPF works as expected. Next, let's learn how to compute the values of the probability density function. Let's define the start point on the x-axis. I will simply denote the start point like this. It will be equal to distribution dot PPF, and this will be 0. Actually, this will be 1%. Okay, this will be the start point. Next, let's define the end point. Here I'll just change this part. It will be end, and the end will correspond to 99%. Okay, perfect. Next, let's define an array that will start from the value start point axis. It will end at end point x-axis, and in between we will have 500 steps. Let's do that. Here I'll type x value. This will be numpy.linspace. I will start from the start point on the x-axis. I will end at the end point on the x-axis, and in between I will have 500 steps. Okay, so here's the array of x values. Perfect. Now, we need to compute the y values. The y values will actually be computed by evaluating the probability density function for the x values. To do that, I will type y value is equal to distribution dot PDF. PDF is the function for computing the probability density function. And over here, I'll just specify the x values. Okay, let's see our y values. Here they are. Perfect. Next, let's learn how to plot the x values and y values. That is, let's learn how to plot the probability density function of the normal distribution. Here's a script that I wrote for plotting the probability density function. First, over here, I define the figure size. Then, I call this function plot.gca. Over here, I plot the x and y values. I set the color and I set the line width. And over here, I use this very nice and useful function called fill between. The fill between will actually fill the region underneath the normal distribution. I set the x values, I set the y values, and I set this transparency factor to 0.2. For example, transparency 1 corresponds to completely non-transparent color, and 0.2 is actually 20% completely visible. Okay, next I define the title, I define the X label, Y label, I adjust the font size. Over here I adjust the font size of the ticks, then I set the grid to true, I set the X and Y limits, and finally I save the distribution in this file called normaldistribution.png, and finally I plot the distribution. Let's see the graph. Here it is, looks perfect. You can immediately include this graph in your scientific report or in your student homework assignment. Now you can play with this graph by changing the parameters. For example, let's change the color to be, for example, red, and let's change the transparency to 0.5. You can also change the line width to, for example, 6. And let's see the output. Perfect, here it is. Okay, that would be all for today. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons. Thanks a lot and have a nice day.